everyone. Today we will discuss one of the most important concepts of statistics as well as probability distribution. It is known as Gaussian distribution or normal distribution. These words are used interchangeably, and normal distribution has enormous importance throughout the statistical concepts. So before moving to normal distribution, I will start with discussion of what is distribution or probability distribution. So it may be a question that what is distribution or probability distribution? So probability distribution is used to calculate the theoretical probability of different values. So I will write also probability distribution is used to calculate theoretical probability. So I will give an example. If we know the mean and standard deviation, suppose we know mean and standard deviation of height of adult human beings or adult men, the probability distribution of this height of adult men can be used to calculate probability of a male having more than 6 feet height. So it is the use of probability distribution that we can check what is the probability that a particular observation may have value more than, less than, or equal to a particular value. So I will introduce few more terms here. So we have a term as parameter. So parameter are basically for population, so they are also called as population parameter. And the value of population, whatever characteristic we are interested, value of that characteristic in population is called as population parameter. So suppose here we are interested in height of adult men. So this mean and standard deviation of population is population mean and population standard deviation. And it is important to understand one more thing, that all the distributions, all the probability distribution will have one or more than one population parameters. So in normal distribution, we have two parameters, mean and variance. In different distribution, we have less than two parameters also. So we will discuss those things in detail later on. So while discussing probability distribution, it is important to know that few methods assume that your sample or your observations are drawn from a particular distribution. So they assume that population is following a particular distribution, and few methods are not bothered about population distribution and they don't assume any distribution. So they are called parametric methods. Parametric because we are we have some assumptions about population parameters. So from that population parameter, we got a word parametric, and those methods we assume that our parent population may have a particular distribution or called as parametric methods. And in some methods we are not taking any assumptions about our population, so they are called distribution free or non-parametric method. So please remember one thing here, that when we discuss about distribution free, it does not mean that your sample is not following any your population is not following any distribution. Your population will follow a distribution, but you are not bothered about that distribution. You have no idea, or you are not interested to discuss, you are not interested to decide which type of distribution your population may follow. So in that case, you will use distribution free method or non-parametric method. If still your population follows a particular distribution and you are not aware about that distribution, there will be some kind of distribution in that case also. You should remember this. So we discussed few things before starting our Gaussian distribution or normal distribution. So as I discussed earlier, I will focus today only on the Gaussian distribution, and Gaussian distribution is also called as normal distribution. And it does not mean your data follows more normal or less normal that distribution. It is only a normal distribution. Astronomer and mathematician reinvented this distribution. Earlier, the De Moivre and Laplace has contributed for the normal or Gaussian distribution. That's why it is called as Gaussian distribution also. In physics, it is called as error function. So it has two different names in two different streams, and it is a very interesting story how Gauss has derived the distribution, Gaussian distribution. So basically, Gauss was a famous astronomer, and as an astronomer, he was measuring distance of a planet and its satellite, or you can say two celestial bodies. And during night he was observing something, and during day he was free, so he was using mathematics to derive distributions. So when he was observing same celestial bodies again and again, he observed that there is some variation in two bodies. So his measurement have some variations, and when he mathematically derived those variation, he observed that his measurements were concentrated at a point. So that was, we can say that it was measure of central tendency. So he observed that measurement were concentrated at a point, and he also observed that whatever the concentration point, he has plus as well as minus departure from that point. So he observes two main things, and on the basis of these two things, he derived the Gaussian distribution. And the notation of the Gaussian distribution is termed as this one, we call as normal, mu and sigma square. So basically, Gaussian or normal distribution is two parameter distribution. One is your mean and another is your variance. So you have to remember these two properties, that your Gaussian distribution is two parameter distribution. So he has listed properties of Gaussian distribution also, and few of properties of Gaussian distribution is that your observations are scattered over the space, and the theoretical values can take any point between minus infinite to plus infinite. So your observation range is completely open. It can be minus infinite or it can be plus infinite. Your observations will lie between these two infinite values. His second observation was little bit different, and he observed that the height of frequency curve, so height of frequency curve, which is also called as probability density, and it will from minus infinite to plus infinite. So he derived that there is a no possible particular point, and the probability of any such specific value will be zero. He also suggested that the total area under curve is equal to 1. He suggested the curve is symmetrical one and bell-shaped. So he has suggested some properties of the Gaussian distribution. So let's draw a Gaussian distribution here. So if it is your x-axis, so your Gaussian distribution will look like something this. My art is not so much good. So one more important thing to mention in Gaussian distribution, these lines never met in x-axis. So it is your minus infinite and it is your plus infinite, and these lines never met. And what Gauss has already observed, that there is a concentration of values at a particular point, and at that point probability density will be maximum. So that point is actually your mean of the observation, so it is mu. And once you move left side of mu, it is minus sigma, or if it is move plus side of mu, it is plus sigma. So you add standard deviation in your mean if you move left side or right side. It is also important to note while discussing the normal distribution is that your standard deviation should be non-zero. There should be some variation also. A constant can't follow normal distribution. So let's see what is the mathematical form of the normal distribution. And if when we write the PDF of Gaussian distribution, it can be written as fx is equal to 1 upon under root 2 pi exponential of minus 1 by 2 sigma square x minus mu square. So I have a little bit less space there, and it will follow your x will be in the range of minus infinite to plus infinite. So you can observe here you have both the terms, your mu is there and your sigma square. So you have two parameter distribution, and your sigma will be greater than 0. So you can write PDF of normal distribution in this way. no need to worry from this mathematical distribution or mathematical form, because you have to use different softwares to calculate different things, and it is one of most important distributions, so we should know about it. So as we discussed in this curve, that we have this mean, and the deviation from mean to left side are minus sigma, and the deviation from mean to plus side are plus sigma. So position on this graph or in this curve at any point can be expressed as in terms of plus sigma or minus sigma. And suppose we are interested at this point, so it will have some deviation from mu and it will be something sigma. So this distance is known as standard normal deviate or normal score, and it is equivalent when you look values with a normal distribution having mean equal to 0 and variance is equal to 1. So here your x, sorry, it is not x. So your x follows normal distribution with mean 0 and 1, and it is called as standard normal distribution. You can transform any distribution having Gaussian distribution in a standard normal distribution by subtracting all observations with mu and dividing by its standard deviation. So you can convert any data in a standard normal variate, and it will be called as z is equal to x minus mu divided by sigma. So once you know the concept of standard normal deviate and the z-score, I will like to discuss one more property of Gaussian distribution, and it is called as area property. And in this property, we know that if we are taking mean plus minus one standard deviation, it will cover about 68.3% area of the curve. If we are taking mean plus minus 2SD, it will cover about 95.4% area of the curve. And if we take mean plus minus 3SD, it will cover about 99.73% area of the curve. So if you are taking mean plus minus 3SD in a Gaussian distribution, you will cover almost all the observations actually. And from this mean plus minus 3SD, a concept called as Six Sigma concept is developed, and it is generally used in quality performance or quality assurance concept. So basically it is mean plus minus 3SD. So it is plus 3 sigma and minus 3 sigma, both are summed, and the concept of 6 sigma came from here only. So we have discussed the normal distribution, and once we will discuss parametric and non-parametric testing. We will test that our population follows normal distribution or not, and that's why it is one of the most important probability distribution. And it should be mentioned that your sample data drawn from a population may follow Gaussian distribution or may not follow Gaussian distribution. And when you say something that your data is following Gaussian distribution or data is not following Gaussian distribution, you are basically commenting about your population distribution, not about your sample distribution, because there will be an assumption that your sample data is randomly drawn. So once you draw your sample data randomly from your parent population, you will comment only about your population distribution. So there may be a skipped case that your data is skipped and have extreme values, or it may be multimodal case that your data is multimodal. So what means by multimodal? That you have basically more than one mode. So it may be two or more mode. It means that your curve, instead of looking like only this one, your curve may look like this one also. So here you can see you have two modes, actually two peaks. So it is called as multimodal data, or your data may be skipped like this one or opposite way. So population distribution is going to be one of important concept while we will discuss hypothesis testing and various kind of tests. We will discuss how to assess that the data is following Gaussian distribution or not in a different video. If you have any query from this video, please share with me. Thanks a lot.